Right then, question 2. Tricky little question. Okay. Just change that to a 2. Right, so as soon as you get something like this where it says the displacement is something in terms of t squared, t cubed, whatever, okay, you know you're out away from constant acceleration, so you're not using suvat. You definitely haven't got constant velocity, so you're not using speed equals distance over time. You're going to have to differentiate and integrate in order to find things. Okay, so we get x equals a half t squared minus 2t plus 1. Okay, find the times when p is instantaneously at rest, so we want velocity to be 0. Okay, velocity is dx by dt, so rate of change of displacement with time. And everyone tries to differentiate. You don't know how to differentiate things times together yet. You haven't done the product rule. You'll do it next year. It'll be fun. But for now, you need to expand these brackets in order to differentiate. So x equals a half t to the 4 minus t cubed plus a half t squared. So dx by dt is 2t cubed minus 3t squared plus t. And that's equal to 0, because we want velocity to be 0. Factorise out a t, we get 2t squared minus 3t plus 1. That factorises 2t, t, minus 1, minus 1. So we get t equals 0, t equals a half, or t equals 1. Okay. Part B was a lot trickier. It's not a nice question. Find the total distance travelled by p in the interval 0 to 2. Okay. Ideally we want to look at a graph of what's happening. Okay, we know that it's at rest at t equals 0, t equals a half, t equals 1. Okay, so chances are at t equals 0 it's going to start moving from rest. T equals half it's going to stop moving and start moving in the other direction. Then t equals 1 again, it's going to stop moving and start moving in the direction. Okay, so we've got a sort of this thing going on where it's going to move, stop and move back again, stop and then go forwards. Okay, so we need to add together these 3 distances in order to get the total distance. Okay, the best way to do this is to sketch the graph of displacement against time. So we need to sketch this graph here. Okay, you've got a calculator that will do that for you, so you can just plug it into the calculator and put in x equals 0 to 2. So y equals x instead of t, and yeah, just plug in 0 to 2 and it'll do it for you. But if you want to sketch it and you're all capable of doing it, okay, we look at that. That'll factorise to half t squared t minus 1 times t minus 1, so t minus 1 squared. So it's a quartic. Okay, and it's going to have roots at t equals 1 and t equals 0. Okay, and because it's t squared there, it means it's going to turn there, and because it's t minus 1 squared, it means it's going to turn there. So it's shrinking those 2 roots into 1. Because a quartic should cut the line 4 times, but in this case it's only going to do it twice there and twice there. So the graph would come down, turn there, go up, which is good because you know it's flat at t equals 0. It's going to turn again at t equals a half. Come down, turn again at t equals 1. We know it hits at t, turns at t equals 1 because we've done that, and we know it's got a double root there, so it turns. And then it goes up. Okay. And we want how far does it go? So we need to know that length again, and then that length. Okay, so we need to work out the displacement when t equals a half. So when we plug in x equals a half times a half squared times a half squared minus 2 times a half, which is 1 plus 1. Okay, it comes out of 1 over 32. Okay, so it's going to move forward to 1 over 32 metres. Then it's going to stop and come back to the start again for another 1 over 32 metres. And then it's going to move forwards up to this point here. So we also need to know x when t equals 2. Okay, so when we sub in 2, we get x equals a half times 2 squared, and then 2 squared minus 2 squared plus 1, and that comes out at 2. So it's going to move forward for 2. So the total distance travelled is 1 over 32 plus 1 over 32 plus 2, which comes out at 2 and 1/16 metres. Okay. C, show that P will never move along the negative x-axis. Well, we sketched the graph and we have shown that it's never gone negative. That's probably not enough. Okay. Easiest thing to do is say, well, x is half t squared that, so that's half times t squared times t minus 1 squared. T squared is always greater than or equal to 0, t minus 1 squared is greater than or equal to 0, therefore x is greater than or equal to 0. Okay, something like that.